Hello everyone, welcome to IG Bits. We train, you learn. Today we shall revise differentiation sums. Without further delay, let's get started. We created a YouTube channel. Visitors at our YouTube channel at the rate IG Bits. Feel free to subscribe the channel. We started uploading all our sessions in YouTube. You can utilize this opportunity and build your competency. All right. Yeah, thank you. Let's review, the formulas. What are the formulas that you could recall in differentiation? So the first thing is like, we have independent variable and then dependent variable, right? So we were, you might actually doing differentiation with respect to independent variable. So y is a function of x, so dy by dx, isn't it, right? Let's say when in your given sums, if at all you see u plus or minus v, u plus v or u minus v kind of a term, which you are actually trying to differentiate with respect to x, then what that means is you are saying like a du by dx plus or minus du by dx, as simple as that. In case of the product u and v, okay, if you are differentiating uv with respect to x, then how do you rewrite that? U dv by dx plus v du by dx. These are two terms. If you have like a three terms as a product for which you are doing like a differentiation with respect to x, then how do you call it? As two terms you can take a note and then one for which you have to differentiate. Yeah, uvw, right? So uv dw by dx plus uw dv by dx plus vw du by dx. At every instant you have to differentiate one variable, and then variable should not repeat, right? That's why uv du by dx plus uw dv by dx plus vw du by dx. The other one is like a division, u by v. This is a little tricky, but you have to remember the denominator v, right? So v du by dx minus u dv by dx divided by denominator square, v square. Okay. So the other things is like, if you differentiate x with respect to x, then the value would be 1. If you differentiate, a constant value with respect to x, then you say 0, right? Any constant for which the value would be 0 for differentiation. X to the power of n differentiation, n into x power n minus 1. You got to remember, many times you will be using this as well. E power x remains e power x, right? Modulus of x is equal to mod of x divided by x. So log x is nothing but 1 by x. D of dx of log x is equal to 1 by x. Clear? Well, let's see the trigonometric functions. So we have sin x, cos x, tan x, cot x, secant x, cosecant x, right? Let's differentiate each one of them. And what would be, the final? So the formula would be d by dx of sin x equal to cos x. D by dx of cos x would be sin x minus sin x. D by dx of tan x secant square x. D by dx of cot x cosecant square x minus cosecant square x. D by dx of secant x tan x. D by dx of cosecant x minus cosecant cot x. So the cos differentiation, cot differentiation and cosecant differentiation for which you will be getting minuses. That's 19. Okay. And then tan becomes like a secant square, cot becomes like a cosecant square. And then secant is cot x becomes like the product of secant tan, cosecant cot. So there are the hyperbolic functions also, trigonometric functions. There are at times they're asking the questions even here also. So let's compare both of them and then see, like, try to figure that out how easily you can remember. So first three are the positive in the hyperbolic function, sin, cos, tan, for which you get positive. and then a cot, secant, cosecant, for which you get a minuses. That's one difference you can see, right? And the second thing is like sine becomes cos x. Sin x equal to cos x. D of dx cos x is sin hx. D of dx tan x would be a secant h square x. D of dx of cot hx is equal to minus cosecant h square x. D of dx secant hx is like minus secant hx tan hx, right? Differentiation of for cos hx with cosecant hx with respect to dx would be minus cosecant hx cot hx, right? So cos, sine, secant square, cosecant square, secant, tan, cosecant, cot. You can also compare them by adding h's. Only thing is like the sign differentiation is what you have to remember. So we have like a number of ways to remember these things. You do have your own way of remembering things, but at the end of the day, accurately we have to remember these formulas, because these formulas we are going to apply in solving the differentiation sums. So inverse trigonometric functions also we have to remember, right? D of dx of sine inverse x is equal to 1 by root over 1 minus x square. D of dx of cos inverse x is equal of sine inverse, but only the minus is extra. The minus 1 by root over 1 minus x square. D of dx of tan inverse x is nothing but 1 by 1 plus x square, right? So uh, tan inverse is complementary cot inverse. D of dx of cot inverse x is equal to 1 minus 1 by 1 plus x square. Both are same but adding minus. Sin inverse, cos inverse also same but adding minus. Okay, here also cosecant inverse x, secant inverse x. Both actually you will get same, but cosecant will become like minus. Cos, cosecant, cot would be a minus values, right? These are the trigonometric functions, inverse trigonometric functions. These formulas also you have to be remembering them. You have to apply them to actually solve inverse trigo related differentiation functions. Let's recall one more time. D of dx of x, differentiation of x with respect to dx, with respect to x, I mean. Okay, d of dx of x equal to 1. Differentiation of mod of x with respect to x equal to mod x by x. Log x ka differentiation 1 by x. If you see x power x, you got to remember for which the differentiation would be x to the power of x plus 1 plus log x. X to the power of x into multiply times of 1 plus log x. That is how I can read. So a power x ka differentiation a power x log a. E power x remains e power x. One tricky, there are the instances where uh, y is equal function of x. Dy by dx can also be written as dy by du dot du by dx. Du can cut short, and then you will left with dy by dx, right? So for a given problem, you can differentiate dy with respect to u at one go, du with respect to dx is another go, and then multiply them together so it's to get the dy by dx. What is given in your the problem, and then what is an ask. I think you have to make it very clearly without confusion. Okay. So one more thing, we studied like an x power n, right? When you have x power n, then answer would be n into, let me rewrite here. So what we are saying is x to the power of, correct, d of dx x to the power of n. If we have n into x power n minus 1 would be the your differentiation, right? If you look at this one, this becomes what? D of dx x power minus n. Then how do you write it? Minus n into n power minus x to the power minus n of minus 1. That's why minus n, this is nothing but minus n divided by x power n plus 1, correct? So you're written. I hope you're clear, right? Let's solve this problem. D of dx of 5 sin x plus e power x log x, right? So y is given 5 sin x plus e power x log x. You have to remember dy by dx, y with in the function of x. So dy by dx, with respect to x, we are differentiating the y. So d of dx. I don't need to write the next problems, but I'm just giving a quick glimpse. Okay. So 5 is a constant, but multiply, right? You don't need to differentiate this one. You can take it out. So this 5, and then what you are saying is that d of dx is only sin x. Correct? No. So if you look at here, ex log x. So this is uv form. We studied it. D of uv by dx. How do you say? You left with one du dv by dx plus v du by dx. So the same thing at apply here. Let left with one e power x d of dx of log x, right? Plus leave the log x now and apply differentiation for ex. This is what the expansion. Now you apply straight away 5 into what is the differentiation for sin x? Cos x. Very good. Cos plus e power x remains e power x, but log x ka differentiation 1 by x, right? Plus log x remains here and e power x becomes e power x, right? This would be your answer. So 5 cos x plus e power x by x plus e power x log x. Clear? Very nice. Let's try this problem at one shot. How do you solve this one? Apply the rule and then make sure you have an answer. Apply differentiation with respect to x for ex. Ex ka differentiation is how much? Ex only, right? Plus sin x con x u form. So you have to put sin x first and cos x ka differentiation minus sin x. Agree? Plus uv, right? uv. So u dv by dx plus v du by dx for differentiating of these two. So you have to apply the same thing here. First one sin x and then you applied cos x. Now you leave the cos x, apply the sin x, differentiation to sin x. Sin x ka differentiation cos x, right? Cos x. So how do you say now? E power x, what is this one? Sin square x plus cos square x. Clear? So if you know cos square x minus sin square x equal to cos 2x. So if you can rewrite this one, e power x plus cos 2x. This will be the answer. So you have to see that given options, whether the option left with like this or they're actually simplified furthermore. So based out of the given answer, you have to choose one of them would be the right. Okay, shall we move on to next one? Let's try this problem. D of dx of log x base 7, log base 7 of log x, right? So whenever you see log m base n, how do you write it? This one log m by log n, so common base. You can rewrite this also, right? 1 by log 7, you can leave it as a constant, then you can try with log of log, d of dx log of log x, right? Let's assume this is x, log x. So what is the differentiation for the log x? 1 by x. That's why I am not disturbing this, whereas this area I can use it no as a 1 by, so 1 by log x. Since it is not a log x, what I will do, I will differentiate for this also until I reach x point, right? So log x would becomes again 1 by x. So the final answer would be 1 by log 7, 1 by log x, and the log x becomes 1 by x. This would be your answer. Clear? First you have to apply for the differentiation this, then you have to apply inside parentheses, right? This one. I hope you're clear. Let's try out differentiation for what? Cot n power x. What do you have to do? We know x to the power of m cot differentiation, right? What would be n x to the power of n minus 1. Apply the same thing. Let's not think about what the cot or tan, whatever it is. Something power n is what is given, right? Let's apply. So n into cot n power minus 1 dot x. Now what you have to do, since this cot x is a function, you have to differentiate cot x now. So n cot n minus 1x d by dx of cot x. What is this one? Get minus cosecant square x. I think we studied this in the beginning of the class. So your answer would be n cot to the power of n minus 1 x into minus cosecant square x. This was your final answer. Okay. Now let's try the other. This is the problem number 1. Try out the other one. D of dx tan e power x, right? So first we have to apply tan. What is the value for tan differentiation? D of dx of tan x would be secant square x. So this becomes secant square ex. Correct? Because this is not an x, so you have to differentiate that portion e power x. So secant square e power x into e power x ka differentiation e power x only. So the answer would be e power x secant square e power x. Clear? Directly I am applying formula. So why I am doing like a supplementary differentiation here, because I am not just having x here. Instead of x I am using like e power x, one more function inside function. So I have to redo that thing until I get reach x. So if you see e power x, right, now I have x only, the differentiation of x would be 1, right? That's why I ended with e power x level. Similarly, you can try this one without giving too many steps. You can answer this. First I have to apply log x ka differentiation 1 by x. Instead of x, what I have is like tan x. Done. Next thing I have to apply for what? Tan differentiation. D by dx of tan 5x. So what you get here? Tan ka differentiation secant square, right? So secant square 5x. But I am not leaving this option here. Still I have to use 5x. That's not x, no, 5x. So if you can do this, what you would get? 5 into d of dx of x. We know this is 1. Correct? So let me change my pen. 1 by tan x, 1 by tan 5x, right? And then secant square 5x, then 5 and 1. So what I got is 5 secant square 5x divided by tan 5x. This would be answer. You still can simplify it because secant square 5x is nothing but 1 plus tan square 5x. Based out of the option given, you can choose one of them. But otherwise the idea is this way. This is one, this is next thing, this is this also there, that's one. Clear? Very good. Inverse trigonometry का identity sin inverse sin x. Sin inverse of sin x is nothing but x. Always remember. So the dy by dx would be dy by dx would be 1x, right? X for sin inverse of sin x. Straight answer. Sin inverse of sin x would be x based out of this formula. Let's say someone given like you, y equal to sin inverse of cos x. How do you write this one? Sin inverse of sin into pi by 2 minus x, right? So then your dy by dx would be sin inverse of psi gone, so pi by 2 minus is what is left over. Correct, no? Right? Cool. I think you could show like some more problems and then you should be able to understand like how quick you can turn. Next problem, y equal to sin inverse 3x minus 4x cube. When you see these problems like this, right, you have to just use the substitute method. What is the substitution that you can do? If you look at let's put like x is equal to sin theta. So 3x minus 4x cube becomes how much? 3 sin theta minus 4 sin cube theta, which is nothing but sin 3 theta. Correct? So the y equal to sin inverse sin 3 theta. Right? Then this becomes what? The leftover would be only 3 theta. So you have to apply. Theta means how much? Theta equal to sin inverse x. Correct? Now when x is equal to sin theta, theta equal to sin inverse x. So you have to replace with sin inverse x. So actually the problem is given y equal to 3 sin inverse x. Now you can apply dy by dx. What do you get? Sin inverse x problem. याद है ना आपका? What's the value? 1 by root over 1 minus x square. So the answer would be 3 by root over 1 minus x square. Okay. Next problem. d of dx of tan inverse x. What is the formula? 1 by 1 plus x square. Okay. Apply now. dy by dx equal to tan inverse x. Think of this tan inverse x. So your value would be 1 plus x square. Instead of log x, that what I got here is like log x. So just apply the rule as is blindly. 1 plus x square means like a log square x. Then what you have to do, you don't left because this is not an x. You have to differentiate this function too. So d of dx of log x. So then you know this one 1 by x, right? So 1 by 1 plus log square x into 1 by x. That is an answer. 1 by x into 1 plus log square x. Very straight and simple. Agree? Any question? Right. So far whatever we're doing, right, something fall under this sequence. dy by dx equal to dy by du dot du by dv dot dv by dx, right? So when you have like a multiple functions, then you have to just think through this methodology. Okay, so let's straight through you can apply without adding something. dy by dx equal to, first you have to apply for cos, this first term. Cos becomes what? Sine, minus sine. So I put a minus sign. You add everything. Sine log of cot x. Done. Next you have to apply log x. Log of cot x. Right? So it becomes log x means 1 by x. So 1 by cot x. Done. Next you have to apply for cot x. Cot x how much? Cot x. You're right. So minus cosecant square x. This is an answer. You can simplify it, you'll get it. Clear? Let's look at this one. So we have two functions x and y with respect to t, right? So but the ask is like dy by dx. How do you solve this one? You have to apply dy by dt is the first one divided by dx by dt. That is how you can solve this problem. Clear? Let me clean this up. Let's try. First one you can try dy by dt. Apply 3 into sin theta ka differentiation cos t, and then there is nothing like for 2, but sine cube 3 into sine square theta, and then apply for the sine theta is become cos theta. Correct, you know? Very good. Okay. Sine cube. I'm just checking one more time. 3 cos theta to 3 sine square theta, and then sine ka differentiation is cos theta. Right. So if we can 3 come out, 1 minus 2 sine square theta. Similarly, you can say dx by dt. This one, right? So minus 3 sine theta, because cos ka differentiation minus sine, minus 2, and then cos cube ka 3 cos square t, and then cos ka differentiation minus sine t. Right? So how do you apply here? Take the sine theta, 3 sine theta, sine t, because minus of minus plus here. So this is becomes 2 cos square t minus 1. So 3 sin t, 2 cos square t minus 1 is nothing but what? Cos 2t. Right? Similarly here also 3 cos t, 1 minus 2 sin square theta is also cos 2t. So what would be the final? Dy by dx is what you are going to solve. So now it's a straight. So dy by dx equal to the first equation divided by second equation, correct? So 3 cos t cos 2t divided by 3 sin t cos 2t. So what is remaining? Cos t by sin t, which is nothing but cot t, right? Very nice. Any doubts? I'm adding one more time. Cot and a t. That would be your answer. Good one. Next problem. If x equal to a sin theta, y equal to p cos theta, then find dy by dx. So I'm leaving this for you. It's a simple, but you can get it in few seconds. So homework for you. Let's move on. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. All right, so the first review class on differentiation topic is completed. I hope this is useful. You can recap all our discussions and then go through quickly your previous notes and then the previous example paper questions and all. Okay, let's not waste too much of idle time, but spend your review effectively and then build your confidence level. Okay, see you tomorrow. Stay tuned to next session. Thank you all.